We use it every single day. But how often do we really think about it? Today, we're going on a journey through the world of weight. It's something we all learn as kids, sure, but it's also this invisible foundation for pretty much everything in our modern lives. All right, let's dive right in. Okay, let's kick things off with a little challenge for your intuition, pulled straight from a children's textbook. Take a look at this iron almirah, a big metal cabinet. What do you think? Does it weigh about 40 grams or 40 kilograms? Go on, take a quick guess. If you went with 40 kilograms, you nailed it. 40 grams is basically nothing. It's super light. And this simple little question shows you exactly why we need a clear, universal system for measurement. Because without it, our gut feeling can be way, way off. So today, we're really going on a journey of scale. We're going to start super small with milligrams and grams, then we'll jump up to the kilogram we see every day, do a little bit of real-world math with it, and then scale all the way up to tons. And at the end, we'll talk about why this whole system is just so important. So let's begin our journey at the absolute smallest scale, with one of the most precise units of weight we use in our day-to-day lives. So what in the world is a milligram? Well, it's just 1,000th of a single gram. We use it for things where the absolute tiniest amount matters a whole lot, like the active ingredients in medicine, or when you're measuring something precious like gold. And to really help you wrap your head around that, our source material points out that a single ant weighs only between 1 and 5 milligrams. That gives you a real-world thing to picture just how incredibly tiny this measurement is. And here's the magic number. It takes 1,000 of them. 1,000 of these tiny units. 1,000 ant-sized weights, if you want to think of it that way, just to make one single gram. This relationship, it's the foundation for everything else we're going to talk about. All right, so let's zoom out from the micro level and move up to the human scale and see how all this builds into the units that we actually handle every day, especially when we go shopping. Now, the big difference here is just about scale, right? We use grams for the lighter things, like a little packet of sugar, but for the heavier stuff, a big bag of rice, a sock of potatoes, we switch over to kilograms. It's just a much easier way to talk about larger amounts. And the beautiful part is that converting between them is super easy. Just like before, that magic number is 1,000. So 2 kilograms is 2,000 grams. 5 kilograms is 5,000 grams. You see the pattern? It's always just a simple multiplication by 1,000. Okay, this is where it gets really practical. Let's take everything we've just talked about and use it to solve a simple, real-world problem you might actually run into. So let's look at this example from our textbook. Imagine a woman named Rathna is out buying rice. She grabs one bag that's 2 kilograms and 500 grams for everyday use, and then she gets another bag, 1 kilogram and 750 grams for a special festival. So the question is, how much rice does she have in total? To figure that out, we've got to add these two weights together, which means dealing with kilograms and grams all at once. Now, the source shows this really smart way to solve it, using column addition, just like you learned in school. First, you add up the grams. 500 plus 750 gives you 1,250 grams. Now, since that's more than 1,000, you carry the one, that's 1 kilogram, over to the kilograms column, leaving you with 250 grams. Then you just add up all the kilograms, and boom, you get your final answer, 4 kilograms and 250 grams. And what's really cool is this same logic works perfectly for subtraction, too. If you've got a 10-kilo sack of sand and you use up 4 kilos and 500 grams, you just borrow from the kilogram column, just like you would with regular numbers, and you're left with 5 kilos and 500 grams. Easy. Okay, so we've mastered the shopping cart. Now let's zoom way, way out and see how these same ideas apply to really big things, like in farming, shipping, or heavy industry. So first up, we have a unit you might not hear every day, the quintal. A quintal is exactly 100 kilograms. It's a really convenient measurement that's often used in agriculture for weighing big harvests of crops. And then we scale up even bigger to the ton. Sometimes it's called a metric ton. A ton is a massive 1,000 kilograms. This is the standard unit for really heavy stuff. We're talking shipping containers, construction materials, you name it. This chart really helps you see the incredible jump in scale. You start with a single gram. Then the kilogram is 1,000 times bigger than that. And then the ton is 1,000 times bigger than a kilogram. Each step up is just a huge leap. And to make these enormous numbers a little easier to grasp, our source material gives us this fun little story problem. There's a king who donates an amount of wheat equal to 10 times his own body weight. If the donation was 800 kilograms of wheat, we can just do a little quick division and figure out that the king himself must weigh 80 kilograms. So we've gone from the weight of a tiny ant all the way up to a king's massive donation. But why does any of this really matter? Why is it so important to get this system? Well, it's because this system is like the invisible architecture that our entire modern world is built on. It's the shared language that makes global trade even possible. It gives us the pinpoint precision we need in science and medicine. It's the foundation for everything, from a simple recipe in your kitchen to building a skyscraper. It's what connects a single grain of sugar to a gigantic cargo ship. And that really says it all, doesn't it? The source material actually calls this chapter From Tiny to Big, which is just the perfect way to sum up how this one standardized system connects every single scale of our lives, creating order and making sure we all understand each other. And that kind of leaves us with a final question to chew on. We just peeled back the layers on something as simple as weight. So, what other systems that we think are simple are out there? You know, things like time or money. What other invisible structures do we lean on every single day without ever giving them a second thought?